Right, so I'm going to ask you to talk to your partner. But when you go to talk to your partner, I want you to notice things. What did you mean by? These are questions that you could ask if you're confused. This is the big one. Another way I thought about it was, like if you have a different answer, say saying, well, I didn't get that answer. Just say, well, another way I thought about it was this way. Explain your thinking. Not so much like, what did you get for an answer? No. Talk. Have a deeper conversation. Okay, Callie, go with Justin. Jayla and Tatiana, you guys meet up with Otis. Okay? All right, go for it. Talk to your partner about your warm-up. Go. Use those sentence stems.
The part to whole fraction I got was 2 to 5 and 2 to 5, and there's 3 shaded, and a part to part was 2 to 3, and then 2 to 5 for ratio 5, and then I was starting to get
11.1% and then
1 over 9, and then the part fraction was 1 over 8, and then the ratio was 1, and the percent I got was 1, 5, 9.
Okay. So what were the 3 statements that you had to, or the 3 things that I asked you to kind of write about? Justin?
You asked us to compare the shaded area.
Okay.
And shaded area using 3 comparisons.
What were the 3?
Fractions, percentages, and ratio.
So first thing we have to do is understand what those are, right? Talk to your partner about how to make a fraction, how to make a percentage, how to make a ratio. Go. 20 seconds.
How you make a fraction?
I know. Focus. And you need your hand free to write, not hold your hat.
100 divided by that number. And you would also
Rectangles inside the square.
Tatiana, percentage. How do I find a percentage? Because I think this is one of the more trickier ones.
I just pulled for that I don't understand.
Okay, good. Otis.
I didn't do that yet, but I did ratios
How do I find a percentage?
we do 5 divided by 2.
Ooh, you were close. So what you're saying is, you said, hey, if I have that's 5 divided by 2. What do you think about that?
Because the whole part to whole.
Okay. Is this a part to whole or a whole to part?
2 divided by
Aha. Good. I like that. Yeah. Okay. You said this is the whole. That's a part. Why does this work here?
because
Yeah, why?
because 5 is whole and 2 is part.
Okay. You're on a beach in Cabo San Lucas. But it's math class. Okay. What kind of answer am I going to get here, Justin? Greater than 1, less than 1?
It'll be less than 1.
Mm-hmm.
But then you make it like 40%.
So he's saying this is going to be less than 1 because I'm going to get an answer of 0.4. And it's going to be, 0.4 is going to be shaded to whole. What does that 0.4 mean and what do I do with it? Schmitty.
You make it a percent by moving the decimal place this way.
Yeah, I moved the decimal 2 places that way. Why? Why does it go that way? What's a percent based on?
Part to whole.
It is a part to whole comparison. Yep. Connor? It's based on 100%. And I know that if this was a 5, 2, 5, what would be my answer? That'd be 1, which equals 100%. So that's the percentage. Hopefully you got a percentage down for A, a percentage down for B. Peyton, what would be my fraction for B?
Your fraction was you'd have to figure out the number of the whole,
Which is 9.
and only one is shaded, so it'd be 1.
And what am I adding to this?
It'd be the whole.
No, what am I literally adding right now?
The
Labels, units, okay? Because when we talk about ratios and fractions, when we are looking at, 1/9 is a fraction, but 1 shaded to 9 whole, that's a comparison, that's a relationship. That's a shaded to whole comparison. And that's what ratios are all about, is comparing units. It's a relationship between two units. How much? Show me with fingers how much more time you need to get down a fraction, a percentage, or a ratio for A and B. Okay, good. We're all there? You need 5? Oh, how many minutes? 1, 0, 2? Are we good? 1? Okay, I'm going to give you 1 more minute. 1 more minute. You either can do that or you can move on to this one right here. Okay? Go. 1 more minute. Finish A and B or move on to that one. If you've already done either one of those, go ahead and explain your thinking on one of them.
There was 3 that was not shaded, so I had 2/3 apart to part. And then for B, I had a 1/8 for 1 shaded and 8 are not shaded.
It's Friday, school tomorrow, Eli. 9:30 to 11:30. If you're falling behind, this is your chance, Callie, to get caught back up.
Will Miss Harris be here?
Yes. Today we're talking about identifying a constant of proportionality in tables. And we're going to get to that. Talk to your partner about what is a constant of proportionality? What is that? What does that mean? And what's a table? Come on. Nice try.
And the concept, would be like what you do to the original number to get the new number in the table.
Well, that's good. That's really good, Peyton. Yeah. So you said it's what I do to the original number to get the next number in the table. So Peyton said this. Peyton said a constant of proportionality is something that I do to one number in a table to get the next number in the table. But if it's a constant, what keeps happening? Callie?
It's the exact same no matter how many times you do it.
Right? So we have a constant of proportionality of what? 2. Okay? Of adding 2 each time. That's a constant. Every time I add 2, I add 2, I add 2. I want you to think about what we've been talking about when we have equivalent ratios such as 3/5 equals... What do we call that? This action here? A scaling, right? Scale factor. So, if I have a scale factor of 20 here, and then it would be 20 here, if I was to do it again, what would it be? Talk to your partner.
Okay. Well,
So I heard if I scaled up 20 here and I scaled up 20 here, now I have, this is an example of equivalent ratios that have a constant of proportionality. I'm going up by 20 times every single time. So we'll be looking at tables where we're using that, and it's going to help us figure out some missing values. Okay, I'd like you to put your the 2.2 in front of you. I'm going to talk. And just to make sure, Smithers and Blades, right? We're going to, because you guys, did you guys do it yesterday?
Yeah.
Did you? Yeah. Oh, whoops. Yeah, Schmitty. You guys did it yesterday too?
Yeah.
Okay, I'm going to have you do it on Monday too, though. Okay? Looking at problem 2.2. We're looking at this constant of proportionality, and we will get to that. But before we do that, we need to think about what a unit rate is. So I want you to just do some think time right now to yourself. What is a unit rate? And you can look at your examples on your paper. Be like, what? How do these examples apply to what we call a unit rate? All right. Talk to your partner. What is a unit rate? Now that you've read the examples, and you know these are all examples of a unit rate, what is it?
Unit rate is kind of like.
Oh, that was good, Tatiana.
I mean, it's still up there. I can still see it kind of. So.
Sure, we talked about it today, and right? It's something per something, right? Or something to something. So, a unit rate is a comparison. And Tatiana said it right. She was like, it's a comparison of something to something, or something per something. Okay? It's like, up here, we have a unit rate. We don't know what it is, but we do know the two units that go with it. So when I read this, the mystery meat for lunch has, which we do not have mystery meat at our school.
I'm good.
It is a mystery, isn't it?
What's mystery?
So we have calories, 355 calories to 6 ounces. Believe it or not, that's a unit rate. It's not solved yet. Like, it's not just one number, but it's a comparison of something to something else. And my answer is going to be, my unit rate is going to be calories per ounce. For every 1 ounce, how many calories are in there? How do I solve that? How do I figure out what the calories per ounce is? Addie? Okay, divide the numerator by the denominator. Why do you think that's the case? Why do you think I would divide it by that way if it's calories per ounce? Plates?
You divide the calories by the ounces.
Okay, that's exactly what Addie was saying. Because it tells me calories per ounce. That's literally what it tells me to do. So here I would go 6. Top dog always gets the dog house. 6 goes in there 5 times. I get 55. 6 goes into 55 about 9 times. Okay, that's going to be 54. I get 10. Goes in there once. So if I was just keeping it on the left side of the decimal and as a whole number, this would be roughly 59 calories per ounce. And we call that a unit rate. For every ounce, how many calories? 59. So if I said, and this is a true story, okay? Otis loves the mystery meat, okay? He gets those hamburgers and he's like, I don't know what it is, but it's good. And he ate 3 hamburgers, 3 6-ounce hamburgers. How many calories did Otis eat?
A lot.
How do I use that unit rate to help me figure it out? Talk to your partner.
Times 3 is 18.
So I was hearing a number of you guys say this. So tell me if the thinking's right. I heard Austin say, well, 6 ounces, we know that. If I multiply it, that's how much a serving is. Otis, who loves the mystery meat, ate 3 because he took Eva's and then took Jayla's. Okay? His stomach's not feeling great, but it tastes good. He has 18 ounces in his gullet, right? So I use the unit rate to help me figure out how many total calories he ate. So you want to make sure you get this down. Make sure you have this down. These are his ounces, and this is his unit rate, which is calories per ounce. So if this is the calories per ounce, I multiply that by all the ounces. Obviously, I did not give myself some very easy math. 40, 47, 9, 5, 2, 6. So, Otis, not bad, man. Not bad at all. 1,062 calories of mystery meat. He's like, he's probably going to be like, I can beat that next lunchtime. All right, so that is how you use a unit rate. So what could I change? What would I change in this equation to find out a different amount of calories? Talk to your partner. What would I change and why? What would I change and why? How do I change in that equation? To say, find out how many calories Connor ate. What do I change?
We said he should change his diet because 3 burgers a day.
I want to know what. So Cam, I have 3 numbers up here, right?
Yes.
I have the ounces, the calories per ounce, and I got the total calories.
Yes.
So if I want to figure out how many calories you ate of the mystery meat, what would I change?
Well, you'd have to find out like what I ate first. Like if I ate. Am I doing this right? Yeah.
Say-
How many? Yeah. How much I ate? Like
How many?
burgers.
Yeah, how many ounces, right? How many burgers you ate? Did you eat 1 burger? You ate 3, right? But that's going to change this 18, isn't it?
Yes.
Okay. So you can see the unit rate is going to stay the same. So here, to go back to what I'm talking about today, how would I use this in a table?
I know.
How could I make a table with a unit rate?
I know.
Turn your paper over. I'm going to give you 2 minutes. You get to create your own unit rate. And you get to create whatever table it is. Just do 3 or 4. Ready? We're going to have 2 minutes. Go. Create your own table with the unit rate. See what we do. So I made just a really quick, and I got some ideas from a couple different kids here. Obviously, my table is going to be in ascending order or descending order, with the smallest ounces up top to the larger ounces on the bottom. It doesn't have to be one step at a time. But 1 ounce, I know my rate's 59, so I ate 59 calories. If I ate 2 ounces, let's say I take 2 bites of my hamburger, 118 calories. 3 bites, or 3 ounces, 177. If I'm like Otis and I eat my full hamburger, and then I take Eliza's hamburger and I start eating that one, okay, and I eat 10 ounces, 590. So you can see there's a scale factor from each one of these. That scale factor is my constant of proportionality, which is my rate, my unit rate. That increases every time. Today, we'll get to the hamburger problem tomorrow more. That's a juicy one, and I mean that literally. Juicy problem. It's a good one. And it's one that's actually quite real. Today we got B1, B2. You're going to have to find unit rates in there, and especially over here in A. Okay? I'll get that chart because it's in the printing. And then B. So, start off on B1 and B2. We will pause and have some discussion about B1 and B2.
Do I want us to work with a partner?
Yes, you can work with your partner, but obviously do some independent work as well. At the end of the unit, like each unit. Or end of the quarter, sorry. Quarter. End of each quarter. Mm-hmm.
I can't believe it's already high.
Looking at Addie. Addie's already reading. Thank you, Addie. Thank you, Callie. Already reading. What do you think? Yeah. So finding the difference, right? Does finding the difference show us which one if they're equal proportions?
No.
So how do you know that? Like, how do you know that finding the difference doesn't show us that they're equal? Or in this fact, it says the large table is going to get more pizza.
Mm-hmm.
Doesn't finding the difference help us the rate between?
Is it going to show you the rate between?
No, it's going to show you the difference between them.
Yeah, which one has more and which one has less.
Yeah.
And how much more one of them has, right?
Mm-hmm.
So how would I find out if they share a rate?
You divide them.
I would have to find the unit rate.
Right, yeah.
Okay. Would I compare those unit rates?
If you wanted to find out which one gets more pizza.
Work together. Work together. You guys are good. Work together.
Doing Tony's reasoning there.
So the question's asking me, do you agree with her reasoning?
I don't know.
The difference here, blah, blah, blah. The large table has more people, so the people at the small table will get more pizza.
Yes. I agree with that because
That's what I was kind of looking for, is this because over here. Because you're not, like, what kind of mathematical logic do you have to support that?
I don't really have anything like that.
So if I'm sitting down at a table, and I'm trying to figure out which table gets more pizza, what am I going to do? Because I know you like pizza.
You have to find out how much each table gets and how much portion each table.
Okay. And then when I know those two numbers, when I know how many slices each person gets,
You divide them.
okay, then, well, I know how many slices there are total.
Ratio fraction.
Okay, how many people I have, or how many slices I have, how many people I have. What's that answer give me? What do we call that? You're saying, hey, we want to know slices, and then you said take slices and divide it by the number of people.
Then make a percent.
Okay. What would be my unit when I divide? Slices per person. So this is going to be a slices per person. What do we call this answer? We just talked about it. Oh, not a ratio. It's a rate. This is your unit rate. So if you find, now that you know what unit rate is, how would you use it in that problem between the small table and big table?
You would take the total amount of pizza and you would divide it among the people.
And then you're going to get a rate, and then you're going to get another rate. Right? You're going to have a large table rate, and you're going to have a
Small table.
and then you can decide which one actually is the better table to sit at.
Can I use the calculator?
No. Next unit.
I'm using myself.
Just what I was talking to him about, right? So it's asking you, is her thinking right? The difference of 10 and 4 is 6. Where'd you get the 4 from? Where'd you get the 10 from?
The 10 people before the pizza.
Aha. Okay. Now, does that make more sense now?
Yes.
Okay. Right. That's where. So tell me, is that how we figure out where we should sit if I like pizza? oh, there's 10 people there and 4 pizzas. There's a difference of 6. And then, oh, there's 8 people and 3 pizzas. That's a difference of 5. I'm going to sit at the big table, or I'm going to sit at the small table because 5 is less than 6. Is that how we figure out a proportion, a ratio? How do we figure out a proportion or a unit rate? What do I need in order to set up a chart? What do I need in order to set a chart up? A rate. So, yes, I can set up a chart, right? Or, what could I find on the small table? What could I find at the large table? Slices per pizza? Slice per person. What do we call a slices per person? What do we call that? A rate. That's going to tell me, if I sit at this table, I'm going to get this much pizza. If I go over there, I'm going to get this much pizza. So I can figure out which one has, if I don't like pizza, I sit at the one that doesn't have as much, right? If I love pizza, I'm going to sit at the one that has more. Okay? Does that help you out?
So, how do you find out how many slices are per pizza?
How many? Can't see it? 8. Does that make sense? Yep. Wait, what are you guys discussing?
She's helping me on B2.
Okay, so this one here. What do you know about it? Have you written down what you know?
No.
That might be a good place to start.
Okay.
Because sometimes, Justin, just alone doing that, you're like, oh, now I get it.
All right.
I'm not saying don't ask Callie. Please do. But I would do a little more independent work first. About 28 pizzas. How do you know that?
Well, so, okay. I don't think 3 is right.
3 what? Why does 28 not make sense?
No, it's because he's asking how many pizzas should be placed on each table, and we did how many pizzas should be placed along all.
Ah, so you're thinking, I got an answer for a question that...
So 28 pizzas should not be on a table that seats 25.
Yeah.
So that's what I was.
Okay, so why does that not make sense?
Because you wouldn't have 28 pizzas for a table like seats 25.
That's over pizza per person. I mean, holy, that'd be like Justin, because he loves pizza, right? He needs like a whole entire pizza. Yeah, you don't have a bunch of Justins. So how do I figure this out?
Okay, I tried doing it.
I love it. That is great. Sometimes doing math, you're gonna get answers, and you're like, wait a minute, I love what you did. Does that make sense? That's one of the things that I asked you to do. No, it doesn't. It doesn't make sense. It can't be right.
So 28 is the answer.
Don't assume.
It is.
Don't assume.
Because that's what we did.
So the camp director has extra large tables that seat 25. What are they asking you to find?
They're asking you to find how many pizzas should be placed on each extra large table.
Okay. So what are they asking you? Pizzas per table. Now, table's not going to work, but what would work that equals the table?
Person?
Yeah.
Okay.
So that's your rate. That's what they want you to find.
Okay, so
They want you to find your pizza per person. So
there's 160 people.
They're not asking that. They don't. They're saying, we know how many. So in math, what does how many turn into? Like what do we use for the words how many?
Times, yeah.
X. Unknown. how many pizzas per person. This is extra large table.
So one person?
On the extra large table?
No, 25.
Aha. We know this. We don't know the value, but we know this is right. What do we know about that we can compare the extra large table to?
There's 10 people for 4 pizzas.
Bam, girl. Okay. Do you see a scale factor? Nice. I love your math. 2.5. So what do we know about this?
2.5. So you have to do 4 divided by 2.5?
4 times 2.5.
Why do we multiply instead of divide?
Oh, because you're going...
Aha. I'm making it bigger. Good. I love your logic, Tatiana. You got good logic. So how many pizzas at a big table? There we go.
You edit your videos.
Otis? You have a question? Cam, focus.
Well, I already knew that there would be 10 pizzas, but I just don't understand this one because.
So what's the question asking you?
How many pizzas you should order once it's at extra large table? I know there will be 6.4 tables.
How'd you figure out 6.4?
I did 25 divided by 160, because I knew there's 160 people, and if you divide by 25, you could find out.
Okay, hold that thought. Okay, go to C4. Everyone go to C4. So Otis is going to talk us through his thinking here. All right. So, Otis, go for it. Talk us through it.
Well, C4 is you're trying
First of all, what do we know? Let's start with what we know.
Well, you know that extra large table will have 10 pizzas.
That came from
C3.
C3. So extra large table equals 10 pizzas. That's how many pizzas go at an extra large table. What else do we know?
That there will be 6.4 tables.
How do you know there's going to be 6.4 tables? Because that's not something I know. That's something you figured out.
Yeah.
What do I know?
I did 106. Well, I know there's going to be 160 people.
So there's 160 campers. Okay, that's what you know. What else do you know?
And then there's
Talk about this extra large table.
and there's 25 people in the extra large table.
25 people sit at XL table. All right.
And so I did 160 divided by 25.
Tell us why you said, I need to know, this is how many campers, that's how many people sit at an extra large table. Why did you divide this by that?
Well, because I knew there's 160 people, and so for each extra large table, there's 25 people. And so if you divide 160 divided by 25, you'll find out how many tables there will be.
Okay, so he has 6.4 tables. Now, let's use some logic here. 6.4 tables.
7.
Why?
Because
Because you can't have 6.4 tables.
It must be 7. Why don't I round it down? Why do I not round down, Otis?
Because you don't want to. There's only 25 seats, and you can't cram those other people in the other tables.
Kids are going to be sitting on the floor, right?
Mhm.
Now, if it's Eva and Austin, that's okay. But I'm not going to have Addie somewhere. That's what you get, man.
Austin's like
All right. Awesome.
Just like, what did I ever do to you?
Love.
Even just like, I don't deserve this.
Eva's like, where'd that come from? All right. So Otis, so now we're going to have 7 tables. What's the question asking me to find?
How many pizzas the camp director should buy?
How many pizzas should he buy? Dylan, why 70?
Because 70 times 10, 7 times 10 to 70.
Okay, now remember, he only has 160 campers, so 10 pizzas actually is going to feed 175 campers, right? It's going to feed 7 tables. 7 times 25. So he's going to have some pizza left over. But this way, he just tells kids, go in and find a seat. And if they fill the table, there's enough. If they don't, they get some extra. And even Austin can have the extra. Okay? Does that make sense?
Yeah.
Okay.
Thank you.
I'd like everybody to go to C2. And I want you to talk to your partner about C2 and try to solve it together right now. Well, hey, I know you figured it out. Talk to him about it. Like, how did you do it? How would he do it? Maybe he did it differently. Thank you.
10 people, and there's 10 at each table, so you divide it.
You find the rate? Tables are pretty easy to do, aren't they?
The rate is, for this one, the rate is $12 for pizza.
$12 per pizza.
And then after I did that, I haven't done it for Honey's Pizza, but then the price of the pizza would be the rate, so then you multiply by the rate.
Good. Did you guys already get through C2? Do you get it? Justin? It's one thing to have the answer, right? I want you to really understand how to do it. So if you do, that's awesome. Will you be willing to explain it up on the board over there?
Did you get any judges that down? How many pizzas?
You said you know how to do it.
You just said no. Good job. You did it right.
All right.
C2.
So, how did you guys approach this problem? How did you approach it?
So first I read the question. There's 160 campers.
Yeah.
And everyone's sitting at a large table, and every large table holds 10 people. So I divide 160 by 10, and I get 16.
So you went 116 campers, and they're sitting at, there are 10 tables, so 10 is people per table?
Yeah.
Okay. So she's got total campers. This is the not extra large table, right? Okay. And she gets an answer of 16. What does that 16 mean? Hold on.
16 would be like how many tables you need.
This is not the rate. This is just tables. Because see, she's thinking this. I have 160 kids, 10 at each table. How many tables? 16 tables. How do you use the 16 tables now?
You'd multiply it by the number of pizzas on each table, which is 1. And
64 pizzas. How did you do it, Addie? Did you do it differently? Did you set up a proportion?
I put.
Are you working on it? You got it, okay. Callie. All right. Did you do a proportion, Callie? Oh. Did anybody do a proportion? What are they asking you to find? So they're asking you to find, wait a minute. So they're asking pizzas per what? Table, right?
Yeah.
Mm-mm.
Or campers.
Yes. Pizzas per total campers. Do I know total campers?
Yes.
Okay, so I know that. Do I know how many pizzas?
Yeah.
No, because that is what they're asking me to. Okay. Tell me. Do we know a pizza to camper ratio here?
Yes.
What is it?
4.
4 to 10. Now see? What's that? 16. What's this? 16. That's how we do it with proportion. All right, Justin, I'm going to... Ooh, bueno. Like it. All right. Please go ahead and put your stuff away. Thank you, Justin. See, you did know how to do it. Where'd you get that from? Please put that away.
Hey, sweetie, you said, please take your stuff away. And look what time it is.
Never, Austin. Never a dull moment with you. Love it. I like having you, Austin. You ask good questions. Okay, guys. Shh. Tomorrow. Hold on. Did she assign 7?
Yes.
And when did you guys do it?
Like Tuesday.
Okay. So good. You'll be ready for tomorrow because I definitely want to go over it.
Tomorrow's Monday. Tomorrow.
Monday. So I'll be going over 7. You got it done? Woo woo.
So we have to hold it.
All right. So wait. So this is what I want you to try to do. Hold on. Here we go. We talked about proportions, Tatiana, and them being constant. What makes a constant proportion? A rate. So up here, or I could write rate as something that makes a constant proportion. What else does? A rate definitely does. Right? It's going to increase by every time. Every time. A scale factor. A scale factor creates a constant proportion. If I keep doing it, multiplied by 2, multiplied by 2, multiplied by 2. Right? So a scale factor does too. Your question that you're asking today is, what do we know about unit rates and using them? Because unit rates are super helpful. Miles per hour. Jelly beans per minute. Yeah, hey. Hot dogs per minute.
I'd choke in that.
Do you know that the world champ ate what did he eat? 92 hot dogs in 5 minutes or something? I don't know, maybe it was 10 minutes. But it's a ridiculous amount of hot dogs. Okay. Oh, bun and all. Oh. Yeah, the Nathan's guy. So what do I know about unit rates? Brayden, what do I know?
You know that it's comparing two rates.
Bam! Yes, comparing two things. Miles and hours. Jelly beans and minutes. Okay? Homework problems per minute.
0.
You have a higher rate than 0, Schmitty. Slices per person. Okay? Costumes per class, right? If you did the blackout day today, that could be a rate. Costumes per class. Hold on. What else do you know? Yeah.
About unit rates.
Yeah, how can I use it? hey, if I know Eva, okay, can run 10 meters in 2 seconds.
5 hours.
Okay? 10 meters in 2 seconds. What's her rate? 10 meters, 2 seconds. What's her rate? 5 meters. Okay, 5 meters per second. So tell me, if Eva comes up to me and says, I am going to run 50 meters under 4 seconds. No, I know her rate. And I'm like, no, you can't. Your rate's only 5 meters per second. And I know 50 meters. So you can use your rate and multiply to find unknowns. I want you to make sure you have that down. All right, guys, see ya.
Have a good weekend.
You too, Hennessy.